I'm Gordon, Student Research Assistant at Center for Technology and Society at Technical University of Berlin. Together with our partners, we've developed the Transport Energy and Emission Calculation tool, TEECT, a comprehensive tool for calculating traffic volume, traffic performance, and corresponding CO2 emissions. Today, I will show you how TEECT works.
In TEECT, the statistical block is used as a spatial unit in the tool. It is an area that is surrounded by streets. Each of them consists of a closed and continuous surface. In some situations, for example in case of different land use, railways, rivers, administrative boundaries, statistical blocks can be adjacent to each other without a road in between. In our test region, there are 14 statistical blocks with 44,832 square meters area on average. TEECT provides two user interfaces to represent the same calculation method: the Microsoft Excel sheet using Visual Basic for applications and the Python-based toolbox for ArcGIS 10. The Microsoft Excel results can also be imported into ArcGIS for further visualization. After the calculation, we will show the results in Google Maps by exporting them to a keyhole markup language file. The first calculation method uses the TEECT Excel interface. For the users without GIS background, this Excel method provides a simple way to enter the necessary input data for every statistical block. On the left side of the user interface is the input window. Here, the user can choose those statistical blocks for which traffic volume, traffic performance, and CO2 emissions should be estimated. The Traffic Properties button on the right side adjusts the parameters of local traffic behavior. In the Output Calculation window, three types of output values can be selected, which are traffic volume, traffic performance, and CO2 emission. Also, on the right side beneath the two windows, the user can find a simple Quick Start guide to help them getting started. In order to choose the number of statistical blocks that should be included in the calculation process, every block can be checked or unchecked in the user interface window. After this process, the Insert Properties and Adjustment Factors button are open for checked statistical blocks. Clicking the Insert Properties button opens a dialog window where different parameters of the block have to be entered. Here, the inputs for the number of residents, the number of employees, as well as the street allocation are already defined. This data can be kept, adjusted, or even estimated in case not all data is available. For the mentioned estimation, the user needs to provide additional data for the share of land use and plot area. After confirming the data entries for the basic properties of the statistical blocks, 4 default parameters for the transport facilities, car ownership, accessibility of public transport, parking lots, and distance to the next shopping facility must be adjusted or confirmed. After the adjustment of basic properties, the user needs to provide more information on local traffic behavior. By pressing the button Traffic Properties, a window appears to adjust different parameters distributed over 6 index tabs. Again, default values have to be confirmed or adjusted. With the confirmation of the traffic input data, the pre-arrangements of the estimation are completed. As mentioned before, the TEECT provides the 3 calculation routines of calculating traffic volume, traffic performance, or CO2 emissions. After choosing one option, a window appears that shows the results of the calculation process. It is also possible to export the results by clicking the Print button. For the users with GIS background knowledge, the developed ArcGIS user interface provides an automatic way to run the TEECT. This interface is programmed in Python, supported in ArcGIS 10. It is designed as a script in Arc Toolbox. Before running the script, the user must save all input data of statistical blocks into one shapefile. In the example, all data is saved to a shapefile named input shape. It includes data regarding the number of residents, plot area, different land use share, street lengths, and street lengths with different speed limits. To import the toolbox, the user must open the Arc Toolbox window, right-click in the blank area and choose Add Toolbox. After finding and adding the toolbox, the script called TEECT can be found here. After double-clicking the TEECT script, the application starts. The opening user interface is divided into two parts. Completing the top left part is mandatory. The user must choose the input and output shapefiles as well as the corresponding fields for all the input data. The second part below is optional. Here all the figures are already defined but can be modified by the user. The Tool Help button, accessible over the corresponding button below, provides further information for every step. After the confirmation or adjustment of all input parameters, the calculation routine can be started by clicking the OK button. The calculation routine will automatically generate a new shapefile with all results. This window shows the resulting attribute table of the generated shapefile. This includes 12 results that can be divided into 5 categories: traffic volume, traffic performance, CO2 emissions by motorized individual traffic and buses, CO2 emissions by person, and CO2 emissions ratio. The generated map shows a possible visualization of the results using the standard classification and symbology tools provided by ArcGIS on the example of a neighborhood in Berlin. This example shows the traffic-based CO2 emission in the area and the land use. It helps to find reasons for CO2 emissions or to evaluate urban and transportation concepts. To make the results accessible for a broader range of interested people, the TEECT results can also be exported to the CityGML database, and then again exported as a KML file, viewable in Google Earth. In this case, the yellow polygons are the statistical blocks, which are highlighted when scrolled over with the mouse. The additional information stored in the attribute table of the shapefile can be visualized with an information box that opens by clicking on the respective block. The information box firstly provides basic information about the block, like block ID, plot area, and the number of residents. The traffic window shows two parameters: the traffic volume and traffic performance in the unit. Below the title, the legend for the components as well as their ratios is displayed. The CO2 emission window below shows CO2 emissions for every mode of transport and the quotient compared with the average value. In summary, as demonstrated, the results of the TEECT calculation help to identify strengths and weaknesses of an area regarding the settlement structure, traffic, and emissions. Thus, recommendations can be derived for future planning.